Okay, so today we're going to try to graph in standard form. So here is the standard form. Let me highlight it for you. It's y equals ax squared plus bx plus c. And so to find the vertex, or to start off with the x coordinate of the vertex, that's called the axis of symmetry. That's going to be this equation right here. X equals minus b over 2a. And so when we say minus b, what we mean is minus -8. And then when we say a, right, 2 times a, we mean this number right here. This is a, 4. So we're just going to plug all that in. So it's going to be negative times a -8 over 4. But we're not going to forget this little 2 here. It's 2 times that value, 2 times a. So this is going to come out to 8, positive 8, right? There's a negative times a negative, so it's positive 8 on the top and positive 8 on the bottom. That comes out to 1. So the vertex, right now, we know that the x-coordinate is 1. That's also the axis of symmetry. So if I come over to 1, I can snap a line right here. That is going to be your axis of symmetry, positive 1. And so then in order to find the y-coordinate for the vertex, I'm looking for this value right here, the y-coordinate for the vertex. What I'm going to do is take that number that I just found, 1, and I'm going to put it into the function. So f of 1 equals 4 times 1 squared minus 8 times 1 plus 1. So this comes out to just 4, because 1 squared is 1, minus 8 plus 1. And so if you do 4 minus 8, you get -4 plus 1. That's -3. So this equals -3. So the vertex is 1, -3. So let's just plot that. That's 1 and -3. So it's down here. That's the vertex. Okay, so far so good. Now when we're graphing standard form, you could try to factor this to find its roots. That's a very valid way to solve this. To try to graph it. We're only looking for 3 points to graph it. Let me show you many ways to do it. First, I'm going to start just by finding the y-intercept. Here's how we would find the y-intercept. We take the original expression right here. We're taking this expression, and what we're going to do is we're going to put in 0 for x. So the y-intercept is where x is 0. Let me do that in a pen. Here you go. X is 0. We're going to put 0 in here and here. And so what's going to happen is that this term is going to go away because now it's 0. And then this term is going to go away because it's 0. And so you're left with 1. That is the y-intercept, 0, 1. So let's plot that. 0, when x is 0, that's right here. And then we go up 1 from there. So this is the y-intercept right there. Okay, and so I don't know about you, but it looks to me like if I were to pick another point, I would want it to be over here in this region of the graph, because I've got my vertex and I've got my y-intercept. I'm just missing something over here, so that's what I'm going to do. And I don't know about you, but I'm looking at the axis of symmetry and I'm thinking to myself, well, if I were to pick, say, x is 2, if I were to pick x is 2, then I would probably get a nice clean even number here. So let's just try that out. Let's pick x is 2 and see what happens. I'm just going to pick a number over here on this side of the graph. So x is 2. Let's put that into the original equation. So f of 2, what is that? That's 4 times 2 squared, oops, parentheses in the wrong place, minus 8 times 2, and then plus 1. So this is 4, so this comes out to 16, minus 8 times 2, that's 16 as well, and then plus 1, well look, these cancel out, and we get 1. So it turns out that this point, it does cross very nicely at positive 1. When x is 2, it crosses here at positive 1. So now I can connect all of this with just my U-shaped graph here, put some arrows on it, and we're finished.